Okay, it is the top of the hour, so I'm going to get started. It looks like there's a few people in the room, so that's great. Basically what we'll do is this is a Q&A, so I will give a brief introduction to myself, my background, my work in writing, and then I'm here to answer questions, and those questions can be anything from science background to sci-fi background to Star Trek background. Although, even though we're right at the end of season 3 of Picard, if you do have questions, I'm going to be a little bit cautious in how I answer those, just for my own, uh, not safety necessarily, but I always feel the eye of CBS is down looking at me. So, all right, a little bit about my background. I am an astrophysicist by trade. I have a PhD in general relativity and gravitational waves that I obtained as part of the LIGO collaboration at the University of Glasgow. I stuck with academia for a little bit. I did a postdoc again with the LIGO collaboration in Wales, in Cardiff. And then I decided that academia wasn't for me. And so I transitioned out. I moved back to the United States and I started working as an educator. I worked as an adjunct professor and as a educator slash performer at the Denver Museum of Nature and Science. Unfortunately, the public science outreach wasn't covering enough of the bills, and so I found myself looking for other career paths, and I ended up getting into aerospace engineering. So I worked as a federal contractor in the aerospace field. For me personally, it was very inspiring because I was inspired to become a scientist because of Dana Scully. So when I had that job, I had the opportunity to put on a pantsuit and go into government buildings, which is like all I ever wanted. But one of the things that when I was working as an aerospace engineer, I really missed teaching. And so I would go to conventions, sci-fi conventions, writers' conventions, things like this, and talk about the science using science fiction as a backdrop. So this would typically be like, how would artificial gravity work? How does faster than light travel work? And those different concepts, and work with writers to try to come up with good ways, as well as critically examine works that have been done in the past. And this could range from like pop culture, pretty well-known things, all the way to the little bit more obscure work, but all very good because I found that using science fiction as an anchor point helped explain a lot of science, whether it was because they did it great or because there were things that maybe they got wrong, but we could at least explain why they got that wrong. And so I was doing this. I was working as an aerospace engineer and I was going to these conventions and speaking. And I did that for about 5, 6, almost 7 years probably before I moved out to Los Angeles. I continued working out of LA Air Force Base, again, as a federal contractor. And but because I'd been at all these conventions, I had met a lot of writers, creatives, everyone else, and I was super excited to start connecting with those folk more. Um, Let me see if there's okay. I'm just checking that nothing's going wrong. All right. So I started connecting more with creatives that I had met on this convention circuit. And because I was in LA, there was a lot of like, oh, my friend's writing this pilot, or they're on this TV show, or they're working on this video game, or all these different media that touched science fiction that they wanted to ask someone with a background in that, and particularly someone who had examined the science fiction aspect of it. So that's how I started kind of working in the industry, in the entertainment industry, but I was still an engineer at that point. And then uh, people at Star Trek had heard of my convention talks. And so I was invited to go to the licensed conventions and speak about the physics and the science behind Star Trek. Hugely popular. Star Trek fans and science fans have a big crossover. And I did that for a couple years. I also did the Star Trek cruise, which is a thing that exists and is very fun. Again, just giving science talks at these events. And then when Michelle Paradise took over for season 3 of Star Trek Discovery, she wanted to bring in a scientist to help with one of the major season plot points. If anyone has watched that, that was the story of like the burn. And so she got myself and another colleague of mine, Professor Mohammed Noor, who's a biologist, to try to think of the biology and the astrophysics behind this idea of the burn, which had to do with dilithium, all these sort of fictional things. And I mean, that's the job, right? Getting to be a science advisor for Star Trek. Because I was in LA, I talked to them about, possibly bringing me on as more of a retainer job. So I would be available to the franchise with all of the products that they produce, be it comics or video games or all the different shows that they have in the pipeline. I would sort of be the go-to scientist for them. And thankfully they went for it. And that was back in 2019, which is bonkers. So I've been doing it for about almost 4 years now. And I absolutely love it. So I've worked on season 3 and on from Discovery, season 2 and on of Picard and Lower Decks, and then from season 1 from the beginning of Strange New Worlds, Prodigy. Oh my gosh, I'm forgetting one. And I did Picard, Discovery, Lower Decks, Prodigy, and Strange New Worlds. Oh, that's all of them. Okay, I just wasn't counting properly on my fingers. So I've been in all of those shows since then. And so if people have specific questions about like plots in those, I could try to explain. Because of my NDA, I can't really talk about season 3 of Picard, even though we're right at the end of it. I don't want to accidentally say something that might say how it's going to end. But I can recommend some great sort of critical examination of the season that some people I know have done that I really enjoyed, and we could encourage people to watch. So again, for people who kind of came in late, the brief overview is that I am Erin. Hello. I have a PhD in astrophysics, particularly general relativity and gravitational waves. I always blend those two together. And I currently work as the science advisor for the Star Trek franchise, as well as a TV writer and producer of short films in my own right. So I'm always happy to talk about those as well. I'm here for a Q&A, so please feel free to put your questions in the chat. I saw one already come in from Bruce. Thank you. So Bruce wanted to ask, how crazy does it bother you when you see a once-in-a-millennium geological event occur for dramatic effect? In particular, Scar's Be Prepared scenes in The Lion King comes to mind. I love that, which was so awe-inspiring that I grew ambivalent about all perfectly placed rising rock towers. I love that question. For me, it's like I'm not a geologist, so I'm a little less sensitive to those, although as much as I do love I freaking love that scene. Scar. I actually have a tattoo of Scar from The Lion King because I love that so much. But I would say an analogy for me, like with space stuff, is like how I feel when like big space events happen, right? That I think one thing that we commonly forget about space is that space is very, very big. And so, yes, while there is a lot of stuff in space, and if you really want to give yourself some existential, not even existential, I think just pure nightmares, you can Google like near Earth objects and look at images of how many sort of mapped near Earth objects there are in space. But yeah, so space is very big. Yes, there's a lot of stuff out there, but the likelihood of things crashing into each other is fairly rare. A great analogy that I give is, our solar system has the sun is the largest object at the center of the solar system, and the nearest star system to us is the Centauri, like Alpha Proxima Centauri system. And if you think about those from a size scale, if you were to make our sun about the size of an orange in Los Angeles, Proxima Centauri would be another orange in Denver. And so just imagine sort of those size scales. And then if we want to send anything there, like how precise you need to be, knowing where it's moving, all of those things. And so talking about like how to close those distances in reasonable times, how stuff can collide, how we can talk about interactions in space. We definitely do see a lot of those. So I'm sorry I kind of pivoted your question a little bit to a little bit more of my expertise. And a lot of it too, and I saw another question come in, but I think a lot of the decisions I have to make as a scientist and as a science advisor is to still allow stories and characters to come first. So if it serves those, then we're going to be more okay breaking the rules. But if the story and characters aren't as dependent on an event happening, maybe like something like Scar's, performance, it's not important to the story that we were seeing those rising rock towers. I would maybe suggest, reframing how we do it, but it makes for a cool visual. So sometimes we go for that. Okay, Mona had a question. Thank you. How did I work with a biologist to apply astrophysics to biological systems? For example, was I creating biological systems that tolerated physics, vice versa? That is a great question. Thank you so much. So, yeah, so for season 3 of Star Trek Discovery, there be spoilers ahead. But they had this idea for the burn, and they had come up with the story arc for it, and I'll get into what that was. And then they wanted to retroactively apply the science to it. And the story that they had come up with was very sort of classic sci-fi, like Ursula Le Guin feeling stories about, that they had this catastrophic event happened. Discovery had flung far hundreds of years into the future, and they arrive in the future to find out that all the dilithium, active dilithium in the galaxy, had basically been shattered in an event that they call the burn. Billions and millions of people and species were wiped out. It's not, and it basically made warp drive relatively impossible, and particularly because they never discovered the source of the burn. And the story in season 3 is that they try to figure out the source of the burn and to find any ways that they can sort of reverse that. And so what we did was the result, the end of the story, again, very Le Guin style, was that it was going to be due to the cry of a child at the death of his mother is what propagated through the galaxy and shattered any active dilithium. Go. there's your science. And for us, one of the things, so I focused, so they told us, it was me working on the physics side, Professor Noor was working on the biology side, but there were ways that we had to integrate that. I focused on the dilithium, which again is a fictional thing that's been around since the 1960s in Star Trek. So it has a long legacy of being referenced, but is still fictional, and we still had to establish what more we knew about it that wasn't going to contradict anything that had been already said in the franchise. And then Professor Noor focused on, like, about this child, what made them special, what made them be able to permeate subspace in such a way, made them survive in this like high radiation environment that had killed their mother. And then the one that really kind of intertwined for us was about the resonant frequency. We used the concepts of resonant frequencies, which is, that idea of like an opera singer shattering a glass, or running your finger along the rim of a wine glass, or the Tacoma Bridge incident from a few decades ago, where you hit a resonant frequency, and when you do that, it amplifies these effects. So again, if you've walked across a bridge like on a hike and you can feel the bridge start to sway more and more with your steps, it requires you to break step so you don't continue to amplify that resonant frequency that you happen to be hitting. That said, that was the sort of core of what we were talking about with the burn, is that this kid cried out at the resonant frequency of dilithium, which caused it to shatter. And I had to come up with ways that the dilithium would permeate subspace, because the signal had to travel faster than the speed of light, but not instantaneously, because the crew were going to sort of black box triangulate the source of the burn as part of the storyline. And then Professor Noor, knowing that he was going to have some tie to dilithium, some tie to subspace, started to talk about, I think about polyploidy was kind of where he brought that from, ways to be able to resist a lot of the radiation that was there, and being born on this specific planet, how that would affect his tie with dilithium and subspace, and we went from there. And if people are interested in hearing more, I'll try to put a link in the Discord afterwards, but we actually wrote an article called The Science of the Burn for StarTrek.com that people can kind of get into more. And if you have more questions, I'm happy to answer. I just want to get to the other ones that we have. And I don't want to harp on it too much if everyone's like, yeah, no, okay, fine, I get it. I want to move on from that. But I really appreciate your question, Mona. Thank you. And Professor Noor and I continue to work together. He's the way he describes it is I'm sort of like the go-to scientist, and then he gets deputized to kind of help come in. And a lot of that is about, and I see Arturo's question, so I'll get to you in a second, but a lot of that is about expertise and comfortability. So when I'm editing scripts, the main thing I do is I just get scripts from shows constantly. And editing dialogue, medical, biological dialogue is okay. You know, I know my basic science, but also having worked as an introductory science professor and working at science museums, I feel comfortable in finding good sourced content that I can then reference and how to translate that to the writers. But I would say where I do step back and ask someone to come in and help me is if we are creating a fictional story based in science. That's where it's like, I don't know enough about, you know, his expertise is genetics and evolution. I don't know enough about that to yes and the story that they want to build and do it in a way that makes sense. So that's when I kind of ask for help. I hope that makes sense. But all right, Arturo had a question. Thank you. What stellar phenomena are Star Trek Stardate supposed to follow? Oh no! And it is assumed that the Stardate is updated simultaneously. Oh, or when the light from the events reaches each world. Oh, that's a great question. So, and Joanne, I see your question as well. Thank you. I'll get to that in a second. And as well to people, feel free to add questions as I'm answering these. But Arturo, so I didn't mention this. I am also now the keeper of star dates for the entire Star Trek franchise, which is not stressful at all. So I'll give for everything we see in Star Trek, I try to have a in-universe and out-of-universe explanation. I don't like saying the phrase like real and fiction, because I think for a lot of us, and I include myself in that, Star Trek is real to a lot of who we are and our ethos and the core of our being, that I don't like to just dismiss it as fictional. But there are in-universe and out-of-universe explanations for things. So the out-of-universe explanation, the pre-Cochrane for Star Trek fans out there, Stardate explanation is essentially in the original series, they just picked one. And these, for people who might not have heard this before, this is, Captain's Log, Stardate, blah, blah, blah. And you hear a series of numbers stated. In the original series, the Stardates were usually 4 digits, 0.1 decimal point. And there was no rule. They just said, pick a number. And then if you say it again in the episode, pick slightly later. So if you have Stardate 1234.5, then the next one would have to be 1236.2. But the next episode could be anything. And so, keeper of the star dates, yeah. And so, in Next Generation, what they did was in season 1, the star dates were 41XXX, so like 41,000 something, point something. And then the next season would be 42 something, 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 point something. Next season, 43, next season. So you could almost equate it to 1,000 star dates per year-ish. And that continued all the way through Deep Space Nine and all the way through Voyager. They carried that on. So I think Voyager ends in like Stardate 58 something something. However many years after the Next Generation started. So that was relatively structured. That's great. Then Enterprise kind of does its own random thing. And so for me, with the star dates, and I know fans have done this, there are star date calculators out there. What I did was mostly based on that TNG, that Berman era Star Trek, where I took any of the star dates that we had that had a corresponding at least year and tried to chronologically order the episodes in the universe chronology. And then literally do a y equals mx plus b for anyone who remembers. That was a linear fit to them. And if there was any outlier greater than 3 sigma, I think I did this like 3 years ago, but I think if it was any outlier so statistically significant outlier, we attribute that to an error in the logs. It's fine. It was an error. Something went wrong. Don't take that one seriously. And that judgment is why my calculator might not exactly line up with some of the more famous fan calculators out there. They're along the same lines, but not. So anyway, so we do have a rule for star dates. We do follow them. Strange New Worlds follows the Enterprise rule, which I love because it's the same era. So Strange New Worlds picks a random number. I still keep track of them just for my own brain. But now that said, the in-universe explanation for why these are differing, in the original series era, the methods for star dates that they used were a combination of the time as well as position and location and speed, so velocity, within the quadrant. And all of that was combined to be a seemingly random number. How you can extract that information, I don't want to go there too much. But then in the sort of TNG era, basically what we do and how we kind of think about it in universe is that there is a Federation standard time, and it does progress. And then your question, Arturo, is fantastic about like, how do you attribute these to stellar events? How do you attribute these? We would sort of say like Federation headquarters, or, I mean, unfortunately the show is fairly, it has to be Earth-centric, Starfleet-centric. So it would be like Starfleet would be the universal time standard, and then everything's kind of based on that. At least if you're going to try to create an equivalent month, day, year, that's going to be the Starfleet standard for that. And I can tell you, it's approximately 1,000 star dates per year. And about, if you're more granular, you can roughly do like 2.5 star dates per day. And then in the Discovery era, we also have star dates. They follow the same progression, but they had a different start point that we attribute to the burn because of story. So that's kind of the story behind the star dates. There is a rule. I have not been allowed to publish my equation yet just because of, CBS PR. It's a big franchise. You want to make it a big thing. And I also don't want to step on any fans, but I will say we're probably going to reach the point, at least in the next couple of shows, where people can reverse engineer what we're doing. And they can figure the equation out. I would love to be able to share it. I'm not trying to be secretive about it. I just do what the CBS overlords tell me. So, okay, now Joanne had a question. And if I say anything that sparks more, like, feel free to put it in there. I'll come back to it. Joanne had a question. I have a magic-based system that uses light and shadow. I want the shadow to behave like dark matter. Love it. Do you have good layman resources for understanding the physics of dark matter? Ooh, in terms of resources, I'm looking at my library I have up here. Nothing is jumping to mind, but I can give you a quick overview of dark matter that might help. Because that was some of what we based the fictional dilithium stuff on, which was pretty cool. Okay, so the story behind dark matter for people who maybe don't have that connection. Let me try to rewind a little bit. So Newtonian gravity, Isaac Newton, apple falling from the tree, force equals constant of gravity times the mass 1, mass 2 over the distance squared. People might remember that, or I just gave you flashbacks or not, and all of that's okay. So that's Newtonian gravity, and it works 98% of the time. And this is why a lot of people who go into science in college, some people get very frustrated with it, because then we start to say, oh yeah, all that stuff that you learned, that's actually not the real way. It's just a shortcut for it. And here's the real science. And it's like, what's real? Anyway, Newtonian gravity worked 98% of the time. The cracks started to form when we started to look at the orbits of planets around stars. In our own solar system, Mercury precesses, so it traces out a flower shape as it goes around the sun. I'm exaggerating it a little bit, but that's what it does. And the only way for that pattern to work with Newtonian gravity was if there was a planet between the sun and Mercury. And for the Star Trek fans in the room, That planet was actually named Planet Vulcan, the theoretical planet between the sun and Mercury. Yeah, it's a spirograph. That's great. Um, and as telescopes got better, and we knew Mercury's orbit really well by that point. We knew exactly where Vulcan should be and how massive it would be, where it would be, and we look and there's nothing there. And so then cracks were forming in Newtonian gravity. So around the same time, this is late 1800s, so the back half of the 19th century, mathematicians were also looking at ways to um, express our universe mathematically as a four-dimensional universe. Three dimensions being space, that you can go forward, back, left, right, up, down, and you have control over that. And then time, where time progresses forward at 1 second per second, and we don't have any control over that. So the combination of those four dimensions. Where Einstein came in was, again, the beginning of the 20th century. We have this mystery about Mercury, as well as these theories about treating our universe like a four-dimensional fabric. And Einstein asked the questions, well, what if we introduce mass? And this is the bowling ball on the trampoline analogy that people may be familiar with or have seen on Cosmos or things like that. Where bowling ball on a trampoline will dip it down. You can flick a marble. The marble will start to orbit around the middle, or it will curve off and fly off. And he applied this to Mercury's orbit, and it fit great. They also saw gravitational lensing from solar eclipses where the lights from stars were bent around the sun, so they appeared to be in a different position. Once they knew to look for that to test the theory, they found that. And then since then, 100 years later, they detected space-time itself, the ripples in space-time due to objects colliding, black holes colliding. And that's what I did my PhD on, so fairly close to it. But dark matter, where that comes in. You can think of that bowling ball on the trampoline. You see Mercury going around, you might remember, Mercury goes around fast, Venus goes around a little bit faster, Earth goes around, or a little bit slower. Earth goes around 1 year. Mars takes, I should know this, a longer time than a year to go around the sun. And as you get further and further out from the sun, it takes longer and longer. The return of Saturn, 27 years or something. Now, all right, I see more questions coming in. I will come to them, I promise. And so that's due to the gravity of the sun, and then all the planets reacting to that. Now, they tried to, in the early 20th century, apply the same theory to the galaxy. They said, okay, well, we're good enough now. We can look at a galaxy, see the stars close, how fast they're orbiting, and then look at the stars on the outer edge and see how fast they're orbiting. And we could try to figure out, like, how much stuff is there. And they did that, and there was way too much stuff. The stars on the outside of the galaxy were just booking it around way faster than you expected, thinking of all the dust, the gas, the stars, the planets, everything that we could see. There was nowhere near enough stuff. It's about a ratio of 1 to 5, of like 1 being the stuff we see. There's 5 times as much stuff that we cannot see. That's the origin of dark matter. That continues to bear out when we look at our universe, in the sense that that we can use gravitational lensing, that light getting curved around blobs of something. So dark matter interacts with space-time gravitationally, but it does not emit any electromagnetic radiation, which up until we discovered gravitational waves, that was the only way we observed our universe, was through electromagnetic radiation. Radio waves, X-rays, gamma rays, visual, light, all of that. So that's kind of the idea of dark matter. Now, there's lots of theories about it. And what I did with the dilithium, and we could talk separately. I can maybe answer this in Discord or something else. But what we did with that was, you imagine the sheet of space-time. We think in science fiction about subspace. We say the term subspace. That's the area above and below the sheet. The rules of physics don't count. You can go faster than the speed of light in subspace, because the speed of light is dictated by your traveling on the surface. Outside of that surface, you can go however you want. My theory with dark matter, and there are some theories about this as well, is that there may be something outside of our universe that presses in without actually being in our, like, with it tangibly in our universe. It's outside pressing down. Another way I think about it, if this is helpful at all, I know I can get a little bit in the weeds with this, so I won't dwell on it too long. But mathematically, and especially if you're using an analogy for dark matter, the analogy I use is actually thinking about the real and imaginary planes in mathematics. Now, some of you, again, may be having flashbacks about imaginary numbers. The square root of -1 equals I. I was personally terrified of complex numbers. That's the combination of the two, until I took it as like a senior getting a degree in mathematics, and it finally clicked. So if it's never clicked for you, that is okay. But I think of our real plane being normal universe, and then the imaginary plane being subspace, and then the combination of the two being that are being encompassing the whole universe, including things we can't see like dark matter. And yeah, again, I'll put the link to the science of the burn article because I get a little bit more into this. But because I had that question, I was like, what if like that's sort of the stuff that's dark matter? What if it's pressing on? What if we have like subspace gluons, subspace subatomic particles that we can't see? And that's like dark matter. And then we ended up naming the nebula at the end of season 3 of Discovery the Rubin Nebula, after Vera Rubin, who was the woman who discovered dark matter. So that was nice to be able to honor her. Okay, that wasn't a great question. I hope, or great answer to your question. And that's because we don't know a lot about dark matter. I would recommend, I think there might be a Cosmos episode on it, or a Nova episode on dark matter. If you can find those, I would recommend those. I think those tend to have the best visuals. And then if people are interested in cosmology for your stories, the broader shape of our universe, things like that, there is a I don't have it up here. It's Introduction to Cosmology by Barbara Ryden. I'll put Barbara Ryden in the chat. That is one of the, it's very mathematical. It's like used in classes, but it has some great analogies. So if you just kind of ignore the mathematics, the derivations of it, the introductions to the chapters, the conclusions to the chapters, just conceptually are fantastic if you're interested in those sort of things. Okay, Josh, you had a question. Thank you. Does the science usually get retrofitted once the story arcs have been designed, or do they come to you to help design the story and the science towards each other early on, in the way we're starting to see video game studios build gameplay and narrative from the beginning? Yes, funny that. Great question. So I mentioned my experience with the burn and Discovery. They came to me after the story had been built. And then the next season, they came to me while they were building the story. And this is pretty standard. I think most showrunners, it takes a season to trust a science advisor. This is because in this industry, there are a lot of scientists out there who might be a friend of someone who knows someone who's working on a TV show. They get a phone call saying, can you help with this science that we're doing? And the scientist goes like, no, that's dumb. That would never happen. And then the writer feels sad and they never want to ask anyone for help again. So it's really a trust relationship that you have to build as a science advisor with a showrunner. And so after about a season, the writers, I like to say, I think I have enough evidence at this point to back this up. They see that my philosophy of yes-anding their process, where they come to me with an idea and I go, awesome, let's do it. Let's just try to get the science right, and more retrofitting it. Then they're like, oh, okay, she's not going to make us sad. I suppose we can ask her earlier on while we're coming up with the story. So it does take a little bit of trust to be built. And sometimes that relationship can bear out and flourish into a great collaborative relationship. Sometimes you do still keep the science advisor at arm's length, and that's okay too. It depends on the types of stories that they want to tell and how Because again, if people are familiar with the Star Trek shows that are out now, one of the great thing is that they're all so different. They all feel different. A show like Lower Decks is not going to have the same level of sort of science to it that Discovery does. Discovery's ethos is very much that these are scientists who are sciencing in space. And so they are going to do science and it's going to be accurate, top to bottom. I work from the beginning of the season being built all the way through post-production to get all the graphics right, to get all the images right, or as accurate as can be. With Lower Decks, bless them, love the show. It's one of my favorites. It's a comedy and it's animated, so we don't worry as much about that, and maybe we'll just do a little bit of fun wordsmithing here and there. So it just depends on the tone of the show. And then with Prodigy too, one of the things that I do for that is less about getting the science right and more about the science education aspect, where they're, for those of you who aren't familiar, Prodigy is about kids who discover a starship. They're on the run and they discover a experimental Federation Starfleet starship, and they try to make their way back home because they have nowhere else to go. And I'm getting emotional just talking about it. It's such a good show. It's so good. It's so cute. It feels very other Star franchise in the first 2-part episode, but that was to draw kids in. And then episode 3, they're like, boom, watching Star Trek. And so my role in that is less about getting science right, though that's important, but more about inspiring the future generation of scientists. And I do have a fun story about that as well. But we have more questions here. So Arturo had another question. What's the barrier around the galaxy supposed to be? Yes! Oh, this is such a good question. So in Star Trek, in the original series, the galactic barrier was like this nebulous horror region that like messed with your brain, and it was all like this psychosis that you would get going through this galactic barrier. But in space as we know it now, we don't see that. We don't think that that's a thing. But they went back to the galactic barrier in season 4 of Star Trek Discovery, and they did reach out and they were like, we want to do it as like an homage to the TOS galactic barrier stuff, but like, is there any science we could do with this? And I was like, oh, I don't know, like in our solar system, so you think about our cosmological address. We start on a planet around a solar system that's in our galaxy, that's in a galaxy cluster that is in our universe. Star Trek is all within our galaxy, the Milky Way galaxy. But in our solar system, we have something called the heliopause, which, as you start to travel out of our solar system and you get to the far, far outer reaches of it, you would reach an area of high radiation because there's radiation particles that have been emitted from the solar system going really fast, but just not enough speed to actually exit the solar system. So they build up in this region we call the heliopause. And Voyager spacecraft 1 and 2 have both passed through the heliopause and did detect a high spike in radiation when they did so. So we have literally seen the heliopause of our own solar system. I was like, well, what if the galaxy had a galactopause and radiation particles were able to escape their solar system, maybe didn't have enough velocity to actually escape the galaxy's gravitational field. And so that was kind of how we scienced a little bit of the galactic barrier, that it's like a giant dose of radiation that will happen and that will hit you. And funny enough, I write this up, like get some Q&A back and forth, and then a week later a preprint of a paper comes out theorizing about galactopause formations around galaxies, and I was like, yes. Science and science fiction always have this beautiful relationship, so that felt really good. Great. So Mona asked the question, how do you create rules for fictional physics, like the ring, space, and the expanse? Yes. Do you try to keep things internally consistent? Mona hit the nail on the head. That's the biggest thing, is we're going to make something up and just keep it internally consistent. Create rules. Give yourself rules. Give yourself limits. Create limitations to those rules. You come up with really cool things. The way I like to describe it is that you build a backbone of science into your storytelling, And that allows you to dip into it as much or as little as you want. But if you are gardening the science, you're going to reach a point where you've taken the story in the direction and it now no longer, the underlying science no longer necessarily fits. So regardless of your writing process as a architect or a gardener, however you plan out your stories, I will always encourage to plan out the back science of it. So, like Joanne mentioned, coming up with an analogy for sort of the shadow magic being dark matter. Okay, so let's think about what we know about dark matter. Let's yes and the dark matter, and then we're going to create rules for that. What about dark matter can create limitations, and where can't it? Where do we have to just kind of take it in a different direction? But still, you're creating your own science, you're creating your own rules, and that will help you stay consistent and keep the reader engaged, keep the viewer engaged, that they're going to say like, okay, no, they know what they're talking about. Like this is a thing. And I think that's the most important thing. And then another great way to do it too. So the transporter in Star Trek physically can't work. I'm sorry. It's the rules of particle physics. If some of you have heard of the Heisenberg uncertainty principle, it's rooted in that. It's the idea that as you get smaller and smaller and smaller, you can never know exactly where a particle is. The more you know about where a particle is, the less you know about how fast it's moving and where it's moving. And then the more you get that down, the less you know about its position. So there's this interplay, and then there's still ultimately a limit that you can only, if you're like, I don't care about how fast it's going and what direction, I want to know exactly where it is, you're still going to hit a hard limit with that. That's the Heisenberg uncertainty principle. And that would make transporters pretty crucial. Like if they're going to break me down to all of my constituent components, I really, really want them to know where they go when they're putting me back together. And so that's going to limit your ability to do that. But in Star Trek, some of you may know this already, they created a Heisenberg compensator that is an integral part of the transporter systems. The joke is, if you were to ask me how the Heisenberg compensator works, my response is, it works very well. Thank you for asking. But I love that as an example of like, I know I'm breaking the laws of physics for this story. Transporters are great. We love them. They were a cheat for financial reasons in the original series. We use them until now. And yes, we are breaking the laws of physics, but we acknowledge it. We don't have to explain it. You just acknowledge it and move on from there. And I love that. And you still have your own rules with that. Okay, Crystal had a question. Do you think it would strain belief to have a relatively small planet with quite a bit higher gravity? I've seen stuff that suggests that would be okay, but I don't trust my research. That's okay. Yes, I think it, no, it does not strain belief. Yes, I do think it is possible. Now it depends on the ratio that you're going for, but the key there is not so much size, but density, because density is how much stuff per space you're talking about, and that dictates the mass of the planet, not so much the size of it, but the mass, how much stuff there is, will dictate what the gravity of a planet is. So the gravity of a planet is due to the mass and the radius, the size of it. And so you can have a lot of stuff. You know, our Earth has the crust, it has the mantle, which is liquid, it has a hard iron core. But imagine if it was a solid iron core more than halfway through the mantle, suddenly Earth's mass, you haven't changed it at all, but the mass has increased, the density of the planet has increased, our gravity would increase in that circumstance. That wouldn't be a thing. I'm just using it as an example. But yes, depends. If you're talking about like an asteroid that has Earth-like gravity, that's a little bit harder to sell. But even if you were to say like, oh, it's a incredibly dense asteroid that has near Earth gravity and you don't explain it any further than that, I think you can probably get away with that too. And then, yep. Okay, couple more. The best description of Prodigy. Oh, you're welcome, Josh. Yeah, I appreciate that. Arturo said the best description of Prodigy I've read is a bunch of Star Wars characters who realize they'd rather live in Star Trek. Bingo. Love it. And I'm a huge Star Wars fan too, but I endorse that. Tell the story of inspiring TNG for scientists. Clint asked this question, and then Bruce asked my personal story with Prodigy with that. And then Mona asked a great one that I think we can end things on, if that's all right. But yeah, let me go back. So Clint asked, this TNG, the Next Generation has inspired so many people, but I think Star Trek itself has just inspired generations. I mean, the show now has been around for nearly 70 years, which is bonkers. This universe is almost 70 years old, and that's enough time to have multiple generations of Star Trek fans. And of course, famously, I say, of course, you might not have heard this story. In my world, I'm like, obviously, this story, because I've heard it so many times, but it's a great story. And if you haven't heard this, the first Black woman to go up into space, Mae Jemison, American woman, she was inspired to become an astronaut because of watching Nichelle Nichols in Star Trek. Like, direct X leads to Y. And then the Next Generation itself, with particularly Data as a character, I think inspired so many people. Geordi, everyone sees themselves as different characters in Star Trek, and I think that's what's so beautiful about it. You know, even myself, I was personally motivated in graduate school to finish it because of Captain Janeway. I was big into Voyager at the time, and I just was obsessed with Captain Janeway and everything she represented. And I really felt like if I can't quit because I don't want to let down Captain Janeway. The idea of flip phones, what I'm doing now, the science of like video communication, you can't not attribute a small part of that to people seeing it on screen and thinking, oh, maybe we could do that one day. And that's this beautiful cyclical nature, I think, of science and science fiction, that science fiction inspires scientists and scientists inspire science fiction. And it really is a relationship that is so intertwined. And it's just so beautiful to be able to have that impact. Another great resource, I don't know if people are familiar with, is something called the Scully effect. This is another thing that I am personally a product of, that the Gina Davis Institute for Gender and Media did a massive sociological study in the early 2000s, maybe it was around 2010ish. Anyway, to look at women my age, basically, who watched the X-Files growing up as we were young preteens through teenagers, and looked at their career paths to see if they got into science. And they found a statistically significant difference in the fact that if you were a young woman and you watched the X-Files, you were more likely by tens, like almost 10, 12%, it might have even been higher than that, to go into science than a woman who did not, because the impact of seeing Scully on the screen being a smart, intelligent woman who is a scientist fighting aliens with science made you realize that you could do that. And so that's called the Scully effect. And I'm like a direct product of that as well. And so stories and representation is so important, and how that affects our culture and our lives and our technology is so, so intertwined. Bruce, because I briefly mentioned a thing about Prodigy. So for those of you who haven't seen Prodigy, there's a character in there called Rock Talk. She's a young girl who discovers she's big and bulky, and so she's always had to be a security officer. And then there's an incident that happens. If you don't watch any other episode of Prodigy, watch Time Amuck, because that's probably one of the greatest episodes. It's called Time Amuck. It's great. Anyway, she discovers a love for science. And so she was really a proxy for the viewers, for young kids who want to become scientists one day. And we based a lot of her on my personal story and my personal journey. And I was so honored, because when the kids do eventually reach Starfleet, spoilers, I'm sorry, I can't not, it's a spoiler in it. You don't know how they get there, and that's the important thing. they all kind of scatter and they're investigating Starfleet Academy, and they come up and Rock Talk gets to meet Lieutenant Commander Dr. Erin Macdonald, voiced by me. And I suggest she looked into xenobiology. And so they canonized Dr. Aaron. And the only other person who's played themselves as a character in Star Trek is Stephen Hawking. So no pressure. And he was even a hologram version of himself. So I can't explain how I am in the future in Starfleet, but it made me very, very happy. And then really, really briefly, because we're near the end, Mona asked how you become a science advisor, and I should have a YouTube channel. Thank you. I do have one, but it's very stagnant and very old. So I'm not actually even going to recommend it. But I do want to start putting more science stuff out there. But in terms of science advising, I think if you do have a science background, I would get interested in science fiction, watch, read, get a lot of that. If you're already in that realm, I mean, the demographics here, we're leaning writer focused. If you're interested in screenwriting, television, there is a website called Coverfly. I think fly.com, and then it might be X. But if you go up to the top, it'll have like additional stuff. And Coverfly X is a place where writers can exchange scripts and give notes. And then if you give notes on someone's, you're more likely to get notes on yours. But you can go and sign up and just give people notes. You can filter by science fiction. And that gets you in the zone of like, I've read a script that has a story already established. Let's look at the science, and that just gets you that experience and also a connection with a writer, which I think is really important. So I think putting yourself out there is the best way to do it. And again, to yes and the process and to stay positive and help people tell the best story that they're going to tell. And on that note, I think we are out of time. So I appreciate all of you hanging out in here. I hope I was able to answer all of your questions to some extent. And yeah, thank you. It was fantastic. Arturo, yeah, we're deciding if she's my great 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 granddaughter or if I'm a Q time traveler. We'll find out. But I can't leave without saying go watch Star Trek on Paramount Plus. It is worth it. There is also a Star Trek channel on Paramount Plus Live. Doesn't have any commercials, just randomly plays Star Trek episodes. So high recommend. And yeah, live long and prosper. Thank you, everyone. Have a good one. Enjoy the rest of your con.